And first part of it, we are going to look at installation, root installation. So for the root install, the first thing which you have to do is to actually install the prerequisites. There are a number of them. I have listed them on the website. So if you look at the website and root installation, then under dependencies, I have mentioned it all together. So you have to install all these dependencies. So there are many of them. The way to install these dependencies is that you start with your terminal and then you say sudo. So sudo is the super user command. Sudo apt is the way that you install as well as remove packages in Ubuntu, and then you say install, and then you give the name of a package. So this process we have seen when we installed lamps also, that there were a number of prerequisites which we had to install. Here the number of prerequisites is much more than what lamps requires. To install them, you can put all of them in one go also, but I suggest that you start putting them one by one so that you are more clear about the failure or success. For example, if I want to install the first one, so it is dpkg and dash dev. So I want to see now, for me of course it's already installed, so it's going to say that, and if you are installing for the first time, then it will get installed at this stage. So this is the command, and then when you do sudo for the first time, it always asks for the password. So we enter the password, and then in my case he says that it's already there and it's already the newest version, so he doesn't want to install. So in this way you complete all of them. There are 11 prerequisites. All of them one by one can be installed. After that you have to download. To get installed, you have to download. Here I have given through the wget command, but you can also do it from the browser, web browser. So if you go to this website, that is, so CERN-ROOT it begins with CERN-ROOT, and then all the releases are under releases. So the basic starting point is root CERN, and then there are various subdirectories. One of them is releases. So if you go to the releases, then you will notice that the latest release is 6.24, and it was released on 3rd September. So it is common that the release that you install today becomes an old one very soon, because in this case, for example, June, then August and September. So there are many updates. So you can also go on updating your system, or you can leave it and work with the one that you have installed. So if you take up, whenever you are installing for the first time, so you click the latest release. So this is 6.24, and when you click that, then it takes you to this page, and on this page, if you were to scroll down, you would see that you have available the binary distribution. So always select the binary distribution which you want to install, and so if ours is Ubuntu 20, then I must click this one. So I just make it a bit bigger so that you can see it well. So ours is Ubuntu 20, so we must click this one. When we do that, then this file will get downloaded and it will reach our downloads directory. So this is the next step. Now I should mention at this point that I want you to all install it in this way, because this is better. Nowadays there is another way to install, and that is called snap. So there is another way to install, that is with this command snap, then install, and then it's called root framework. Now I wouldn't like you to install it this way, although if you want to do it this way, you are welcome. The problem is that this snap repository is not, in this case it's not 100% complete, so there would be some components which would be missing, and later on when you want to do lamps linked with root, then it would fail. But in other respects it works. So if you just want to do only root, then this is also okay. If you do through this method, snap install root framework, then you wouldn't even really bother about where it gets installed. You wouldn't have to set up the path and issue this command which will enable you to run root from other place. Everything will be done. So ideally this is a good way to install, but unfortunately it has some limitations that they haven't taken care of one or two components. Maybe they will take care of it in the future. So at this moment I want you to avoid the snap installation and instead do it by the method which I have outlined, namely install first the dependencies, and after finishing that then download the particular binary for your system, and having done that, then shift it from your downloads folder, bring it into your home directory. So here you see that this is the what I have downloaded. Now this is actually 24 version 6.24, whereas what I showed you just now was actually 6.26, because I had installed it some time back, and that time this was the latest. So when you install it could be a newer one, but the process for the installation is going to be the same. So having got this tar, now you know this is just a tgz file. One of the abbreviations for .tar.gz is .tgz, which I have been using. Here they are using .tar and then .gz, which is the same thing. So I think all of you know how to unpack it. When you unpack it, then the unpacked result will appear in the directory root. Now to demonstrate this process for you, because I have already installed root and it is already running. So if in my case, if I were to at this stage type root, you will find that root is already running. But I want to demonstrate to you, for those who are installing for the first time, that root is not running. So what I am going to do is I am going to go to my directory, to my file browser, and I'm going to get rid of this root which I already have. I will, just to be on the safe side, I'm going to rename it as root underscore old, let's say. So this now is sitting here, so it's gone. It's as good as being not there for the present purpose. So it's called root old, and now because my path to this root has been set in my .bash rc, so it will not be effective anymore because the directory has got changed. So now if I try to type root, then it doesn't work, because it says that this file is not there, because this is the command I need to run root from another directory, and that command is not working because the directory has been renamed, so it is failing. So let's start from here. So this is the situation for you, that root is not installed, and what you have to do is that you have to unpack your root binary distribution which you have downloaded. So from the downloads folder you have shifted it here, and now we are going to unpack it. So all of you know the command for that. It is tar, then extract, unzip, verbose, and then file, and then the name of the that's root underscore. So you can just type something and then put tab, so it will then pick up. So this is the command which I will have to execute for unpacking. When I unpack it, then in my directory where now there is no root because I have renamed it as root old, so root will get created. So here I am unpacking. It's a short command, so I'm executing it. So you see now it is going to unpack all the files. So it finished. Now if you look at your directory, then see root has got created here. So at this stage, the next job for you is to make sure that it runs for me, because my command is already there in my bash rc, and therefore it will already work. But for you to make it work, you need to put in a command, and that command looks like this: source. First you must source the file which you want to make it effective, and that is sitting in this directory root, and then bin, this is the directory where it sits. I'll just show you where it is, then you will understand. And then it is called as this root.sh. This is the command which is necessary. For me it is not necessary, but for you, when you are installing for the first time, you'll require. So this is, what is this command actually? So if you go inside root, then these are the directories inside root, and one of them is the bin directory, also called binary. So if you click it, then inside here there is a file called thisroot.sh. There is also thisroot.csh, which we don't run. That is for the C shell. We are using the shell. So for us it is thisroot.sh. So this file is here. So this is the file that I have to source. When I source this file, then I will be able to run root from any place. So this is the command for doing it. So if you do this, then it would work, but one issue is that it would work only once. Second time when you close this command window and come again, or if you were to log out and log in again, then it won't work. So you need to place this command in your .bash rc. So to start with, just to test it, you can go once, and here I don't have it going. Okay, and you need to edit your bash rc file. So that command will look like this: gedit, and the file to edit is .bash rc, and at the end of it, now by the way, my previous command was slightly wrong, so that's why it was not working. I'll just correct it for you. The correct command is given here. So this is your correct command. So if you want to run it manually, I'll just show you that once. So I'm just closing this gedit window. So my correct command was, it was a problem here. I need to go first to my home directory and then here, not otherwise it was a wrong command. So you see this command now works. Once you execute this command, then you will find that root is working. So if you want to type root, then at this point, then you will find that root is actually working, right? So to make it continue to work after you have closed this terminal window, or if you have logged out and logged in again, it is necessary for you to make this command permanent, and that is where we have to gedit the bash rc file. So you take the bash rc file, and just as we did for lamps, in lamps we had made an alias, here you do a source and you source this file. Source, this tilde stat stands for your home, beginning part of the home, and then Under it you have root, so root, and then under it you have bin, so bin, and then the name of the command, which is this root.sh. So this is what you have to enter here, and once you do that, then the task is completed, and root should work. For to make the command inside bash rc effective, you have to log out and then you have to log in again. And if you don't want to do that, then you can just type this command once, so that at least for now this will work, and later on when you log out and log in again, then it will work and you don't have to type this again. So for the very first time after downloading, and if you want to quickly test whether root is working, then you may like to type this command. But afterwards, when you log out and log in again, then the command will happen automatically from the bash rc file. So this is how the installation of root is to be done. So what are the processes? First we install the dependencies, and the dependencies, there are 11 of them. They are to be installed by using sudo apt and then putting the name of the package which we have to install. And after that we go to root CERN releases, find out the latest release. Then clicking that, we notice that there is a build available for Ubuntu 20, and we are using Ubuntu 20, so we click that. If you are using some other Linux, then you must download the source, you must download that binary. And in some cases, that binary is not available for your particular Linux. For example, if you have Ubuntu 21 instead of Ubuntu 20, then there is no build available for that. So CERN typically releases the versions for an Ubuntu stable releases, that is 20, 22, 20, the even numbers. The ones with odd numbers, they are considered as not the releasable versions, so they don't make a package binary release for that. But if in some instances you do have a Linux installed which is not listed and not available as a binary in the CERN website, then the alternative for you is to actually download the source code of the whole root, and then you have to compile it yourself. So that is a big task, but occasionally you need it. It depends on the situation you are in. I am not explaining that part because it's more time consuming. If any of you have this issue, you just contact me. I'll help you to install root on your system if binary package is not available. So this completes the installation. Now that root is installed, then I should tell you that what we are going to do today is only the root command line. So later on you will see that there are three aspects or three ways of running root. One is command line, the second is called macro, and the third is a complete compiled executable file. So to start with, we will go through the command line of root and begin our learning process. And so now let's see. First you need to know what is root. So, and you also need to know what root is not. So many people think that root is an analysis program. Just as you have got lamps which analyzes the data, so you think you have got something which is written by the people in CERN, and it's root, and it's a very big package. It does many things. But despite it being a very big package and having many features, maybe 10,000 features compared at times the features which a program like LAMPS has, but nevertheless it doesn't analyze your data. You have to write a program under root in order to analyze your data. Whereas programs like LAMPS, which are in size also 10,000 times smaller, they actually analyze your data directly without your having to write any code. So the thing is that root is a very big package. It is meant for many things, not just for analyzing data of nuclear physics. It was mainly developed for high energy physics people. Of course, it is very useful for nuclear physics also, and it can do everything what you want to do. But you have to program it. Whatever you are doing, you have to finally write programs under root, and then only it works for you. It doesn't work without coding. So it's necessary for you to know C++ and to know it well if you are to make progress with root. Second thing about root is that the learning time, what we call the learning curve, this one is very long. So it could take 1 year to learn root to some good extent. What we are going to do here is to learn root in only 4 or 5 days. So obviously your learning will be at a basic level. But the trick here is not to worry about this so much, because you can refer to the root manuals, you can refer to the root tutorials. So many references are there. I will point you in that direction. So when during your analysis a particular requirement happens which you don't think you don't know, which you have not learned in these 5 days. So I'm going to teach you root in 5 days. It will not make you an expert, but then it will make you a good root user, enough to say that you know root. So 5 days will be sufficient for you to learn root. Beyond that, to become a root expert, you can always refer to the commands and other things right from the manuals, and you can take care of writing root programs. Working with root is much harder than working with lamps. Lamps, you just start it, place your data, and then analysis starts. But in root, it's not like that. You have to write complete big programs. You have to write them, you have to debug them, you have to understand them, and then only root works. So root is a long process. Even if you know root, you can't analyze and get results from your data on day one. So if you are working with root and you have data and you want results from it, then be prepared for a long session, maybe month before you can have results. But the same thing in lamps you can do on the same day. So root is basically a more time consuming process. To go around that, many of the labs, foreign labs, they write the root skeleton program which is working for that particular experiment. So after you have completed the experiment, they make that root program available to you, and they expect that if you run it, then you will be able to analyze your data. So they make it shorter for you. For that to happen, you should again know root very well, so that whatever program is given to you, you know how to read it carefully, understand it, make changes. And those programs will be typically quite long, several hundred lines long, or maybe thousands of lines in length. You will have to read and understand all those root lines before you can proceed. Okay, so let's get started with the root command line. The root command line is called as the C or C++ interpreter. The short name for it is CINT, Sint or C command interpreter. To start that, we type root. So root now starts. You can start it from any directory. So root is now started. At this point, you can see that my root is 6.24, and if you download later one, you will be able to get 6.26. Now, the very first thing which you need to know is how do you exit root. So having started root, you are at this place, and this is the root prompt. The bracket 0, this indicates the command number. So as after you type one valid command over here, then the next command will come with the number 1. And in order to leave root, the command is given here, namely .q. So .q is for leaving root. You can try it now. So if I put dot and q, so .q, then I will exit root. So you see I have come out of root. Now I start root again. So I am here. So what is root at this command level? It is a C++ interpreter. Means if you write one line of C coding, it will interpret it for you. Interpret means it will run that one line. You know that in C or C++ you generally write a big program which starts with main and then has a curly bracket opening and so on. And also there are headers. So in root, the headers are, when you do from the command line, most of the headers are already there. So you don't have to put. So you don't have to start with hash include for most of the common headers. They are already included. And you can, and another thing is that in C or in C++, we have to declare all variables. So in C or C++, if you had some quantity x and you wanted to give it a value, say x equals 0.53, let's say you wanted to do this. In C, you couldn't have done it. You would have to first say int x, because otherwise it would say that x is undeclared. But not so for the root command interpreter. He will automatically realize that you want to put x, and so x in this case is not an integer. He will assume that it is double. So because it is having decimals, so it can't be integer. It could be a float or it could be a double. So he will take double. So if I just type x equals 0.53, then it will take this value and he will assign x automatically. This is called as an implicit declaration. So x is not declared, but still this command goes through. But now a very important point. You perhaps know that at the end of every C command, we are supposed to put a semicolon. And here when we do root, you have either with semicolon or without semicolon. So I can type it even without the semicolon, or I can put the semicolon. But the meaning of the two is different. Some people think it is same, x equal to 0.53 or x equal to 0.53 semicolon. They think, okay, so root is going to accept it. So it should work. I should be able to do it. But no, they are different. They have a different behavior. I show you what I mean. So let me start without the semicolon. So x is equal to 0.53. There is no semicolon at the end. I am going to press enter. And when I press it enter, then you see 0.53 is what the value is. But if I were to have put the semicolon and then done it, then it is quiet. It takes the command, but it doesn't display the value. So the semicolon then is to be used when you don't want to see any output. If you want to see an output, you have to, suppose now there is x and I want to see what is this value. I now know that its value is 0.53. So you can just put x and without any semicolon you can press enter and then he shows you that x is 0.53. But what is x semicolon? It doesn't make any sense at all. So he doesn't do anything. X semicolon. He doesn't do anything. Now let's put another quantity. Let's say y. You can also put two quantities on the same line. So for example, if x, I want to put 0.53 and then I want to put on the same line another one, so I can put let's say y is equal to something, let's say 0.72 for example. And so after x there is a semicolon, but after y there is no semicolon. So when I enter it, then it shows me only the value of y. If I had put the semicolon after both of them, then it wouldn't have shown anything, but the values that would have got set. Now if I want to add these two numbers x and y, if it was in C, then x plus y by itself would be meaningless. I would have to assign it to z or some other quantity. First I would have to declare z, then I would have to say z is equal to x plus y. But here is an interpreted language. So if I just want to add x and y and to see the result, then I put x plus y but without the semicolon. And then it should give me the answer. So it has given me the answer. X plus y is 1.25. So that's how the basic part of root is working. You can also use the normal C++ or even C commands. They are available to you. So these are extra beyond normal C. For in C, what would you do if you wanted to add x plus y and you wanted to display it? In C++, you would have said C out. Okay, C out. Then you would
Sir,
have
any operation can be done with this means x into y or x by y.
absolutely. So all that you can do in any C language, whatever you want to do, you
Okay.
can be done here. For example, you can do x divided by y. Okay, you can do x multiplied by y. You can do anything you like. You can have 2 into x into y, then like that, again into x, for example, then plus, let's say plus 3. Okay, so you can do it, so I mean, this is a rather expensive calculator if you want to do, because you have downloaded such a big, huge program. But this is also there in as part of root, so you can do your basic calculations. You don't need a calculator after this. You can do it here. And so I was explaining that you can also use the cout command, which is C language construct. So cout x plus y, this would also work. uh, End line, and this command, which is a C++ command for displaying the value of x plus y, this is also working, but you don't need it. X plus y is sufficient, but if you want to do it this way, okay, so he doesn't mind, gives you the answer 1.25. And if you are more into formatted output using printf command, which we use in C rather than in C++, so you can say anything you like. The result is, then you want it in floating point, so formatted float. Then you want to go to a new line, \n, and what you want to print is x plus y. You can, this is a C language command. It's allowed here. You can put it and he gives it. The result is 1.25. So these are some basic things. Let's say you want to do something more than that. You want to do square root. Okay, so you know how to do square root. In C language it is a, suppose you want the square root, so you say sqrt, and then you put the number here. Say you want square root of 3. Okay, so you put square root of 3, 1.7, you should get the answer. Square root of 3 it gives. Okay, if you want square root of x, you can do it. You want to assign something, then you can say z is equal to square root x, then z will get the value. So like this you can execute. You can put sine, cosine, functions are allowed, although we didn't include the math.h. You know that if you are a C language person, you know that these commands like square root and all, they can't be done unless you first include. So here you don't need it. If you do it, there's no problem. He doesn't mind. So you could say hash include math.h. If you want to do this, you are welcome. But he doesn't want it because it's already there. So you don't need to do that. And instead of only this, he has also got one more mathematics library, and that is called as tmath. So this was part of the C language, so he didn't remove it. It's available. But what he has done is that he has made another library, mathematics library, and all objects in root, they begin with this letter capital T. So he has stuck to this convention. Everything begins with T. So that's because tree, so tree, root tree से उसने T ले लिया है, just T. So there is something called tmath. So you see how the color changes when I type tmath, because he says okay, he knows what it is. So tmath is a library, and in this library he has put many of the mathematical functions, including many mathematical functions which you will not find in the normal C library. So one of them is of course square root. He repeats it. Square root is already there. But now this square root is different than that square root which is in the C library. To distinguish between the two, although the answer will be the same, he uses capital S. So square root 3, when you want through the root library, then you must put it with the capital S. But then this header is not this class, this tmath class is not there by default. So if I put only capital and then square root 3 and try to enter it, then he will say it's not found. So he says that this was a mistake and he didn't find it. That's because this is inside tmath. So if you want to use tmath, then you should make it clear that you are going to use tmath. So you put tmath and then you put the scope resolution operator, 2 double dots, and then the color of the word tmath changes. So he gives you a hint that you are in the right direction, because if you had typed the spelling wrong, then the color would not change. Now it is valid. So tmath scope resolution operator. So the scope of capital S square root is tmath, and I click it and I get the answer. The answer is of course the same as the normal square root, but he's got many more functions in tmath apart from the ones which are there. So he has enlarged the library. To give you one or two more examples, suppose first let's start with what is the value of pi. So obviously when you do maths in C language, you encounter this situation that you need the value of pi and you don't want to set the value of pi yourself, 3.141592635. You don't want to go on setting it for all your programs. It should be somehow built in, and that built in the case of pi in C language is called m, that's m for maths underscore pi. So there is a quantity m pi, it is defined, and if you just want to see whether here also it is defined, and you just say m pi and return, and he says yeah, he knows it, it is 3.1415927. So he knows the value. And the same thing in tmath is also there. So tmath, then scope resolution operator, and in this case it is called pi with capital P and small I, and it is also defined as a function, although there is no argument to it. So if I do this, then also I will get the same value. So it has come. You can try now to have a look at some of the other functions on your own. For example, let's say you want to know the cos. So if you were doing cos with a small c, then it will be the usual cos function which is available in the C library. And so in C library, I want the cos of pi by 2, and cos of pi by 2 is supposed to be 0. So I'm doing from the C language library, so I will put m underscore pi and then divided by 2. Okay, you should actually put 2 and then you should put decimal also, but you need not. So if I put cos m pi by 2, then I should get the answer as 0. This is what the cosine function is, pi cos of pi by 2. So here is the answer, 6.12 10 power minus 17. So that is almost 0, and you have the answer. If you want to do the same thing exactly but from the tmath library, then you can put the cos with a capital C. First you say I am using tmath, so you put the scope resolution operator, then you start the cos with capital C, and then you say cos, and then inside the bracket you want pi, so you can use the tmath wala pi. Tmath wala pi is written as pi like this, and then you want to divide it by 2, and okay, 2 is a real number, so 2 dot. Now this should give you the same answer, that is 0. So essentially 0, 6.12 10 power minus 17. So those of you who know a little bit of C language, you perhaps have heard about namespace. So if you are going to do a lot of maths, you can as well declare it permanently. So you can say that I am going to use this using, you say using, and then you give the name of the namespace. So my namespace tmath, I declare it permanently. So for this session, tmath would be defined using namespace tmath, and here I should put the semicolon to make it a valid statement. So I have made using namespace tmath. Now if I were to try the previous command like this, I don't need to specify now tmath anymore because I have put it in my namespace variable. So I get a much shorter. So now I can do this, but without using namespace I could not have done it. So you see, again I have the answer. Okay, so this is your lesson, short lesson beginning root. You have learned how to use root as a calculator. You have learned how to use tmath library of root, and everything has been done from the command line. You have some idea now about how to start root. You know how to quit it by putting .q. You learned about namespaces. You have learned about how to use the command line as a simple calculator. Now there's a lot of things to be done. We will not cover all. We will cover what is of our interest. So our interest is histograms. We have seen what a histogram is when we did lamps, and we understood, and I gave you some examples of histogram. In physics we call them as spectra. So basically what I am teaching you is that part of root which will be useful to you for analysis of nuclear physics data. You can say nuclear physics and high energy data if you like, but actually high energy data is a bit different and more than what we are used to doing in nuclear physics. Nowadays the areas are overlapping, so a lot of nuclear physics is moved into what was earlier thought of as the quark gluon plasma is an example where you have people working from nuclear physics as well as from high energy physics. So don't worry whether I call it as nuclear physics or high energy physics. But within the country, if you are doing the experiments, then it would be usually in the domain of low energy nuclear physics. And if you are doing the experiment at CERN, the chances are you are doing more of a high energy physics experiment. And then there are so many facilities coming up now, and collaborations are going on, like New Star, for example. So there are so many collaborations. So the area of interest is both nuclear physics as well as high energy physics to some extent. So I am covering only those aspects which are of interest to us from nuclear physics and little bit of high energy physics. But high energy physics people who are into really strong experiments at CERN, they would have to learn a lot more and things than what I will be able to explain here. So this part which I am explaining now is of course for everybody 1D histograms. So we are going to start with one-dimensional histograms. So histograms are of three types: one-dimensional, two-dimensional, and there is also three-dimensional, which we didn't introduce. I will stick with 1D and 2D histograms. Now in lamps there were only two options in histograms for the type, and they were called as double word. That time I called it as, I'm just typing it here, not that these are actual commands here. So I told you that there is double word. I had also told you that there is single word. And I hope by now that you know what it means is that double word was 32-bit and single word was 16-bit. This refers to the content of the histogram. That means the counts. What is the size? So a 32-bit quantity can hold the counts to 2 raised to the power of 32, or 2 raised to the power 32 minus 1 actually. And a single bit 16-bit thing would be going up to 2 raised to the power of 16 minus 1. But in the case of root, the convention is that you allow negative counts also. Lamps doesn't allow negative counts. So in root we allow the counts even to be negative. That happens, for example, when you subtract two spectra. But otherwise negative counts are not meaningful. So in lamps it was not coded with negative values. But root is more general, so it's not restricted to only nuclear physics data. a quantity which you are histogramming need not even be even in physics. It could be something to do with some other field altogether. So they have made it more general. So 32-bit histograms, they let's say 16-bit histograms, they would have counts from -32768 up to +32767. Whereas in lamps, 16-bit um, thing would have gone from 0 up to 65535. So they take half the value and allow negative also. And of course 32-bit, that is much more. And then he has more types also. So he has also got 8-bit, which in lamps is not there. So 8-bit is also called as byte, and the range for 8-bit is -128 to +127. So I'm typing these things here so that you can read them. These are not actual commands in root. I'm just typing it for here so that you can see it. So 16-bit would be -32767 to plus, so -32768 actually, to plus 32768. In the case of 32-bit, the range would be a much bigger number, which I won't be able to type for you, but it's 2 raised to the power of 32. So half of that, so 2 power 16. From 2 power 16 with negative sign going up to plus 2 powers, 2 raised to the power of 16 minus, yeah, this should be actually like this. So these are the ranges that you have for root histograms. So root histograms in 1D, if I were to list all of them, then there are 5 different types. So you have T. All histograms names will start with, as I said, T. This is a convention. After that, H1 means one-dimensional histogram. H2 would be the two-dimensional histogram, and H3 would be three-dimensional. So today we are doing only one-dimensional, so TH1. But TH1 then is divided into 5 types. So you have got TH1C. So C means, C stands for character actually, that means byte. So this would be having the range for the counts going from -128 up to +127. Then you have TH1 short. So this is short integer. Then you have the normal 16-bit, 32-bit. So short means 16-bit. So this is short integer, so it is 16-bit. Then you have TH1I. That means it is 32-bit, integer type 32-bit, normal integer. But interestingly, he allows so you might expect that this is all. But actually he has got also TH1F and TH1D. These two, that is floating point F, and double is also floating point, double precision. So why does he have this? Because these are actually counts, and count should be integer. F is floating point, D is also floating point. How can you have fractional counts? And the answer is that he allows, because he allows the spectrums to be manipulated. And as I said, this is not necessarily for spectra as we are used to. It could be used for other things also. So if you were to take a spectrum which is having integer counts and you were to multiply it by 2.5, then you would have fractional counts. Or if you were to make some subtraction, so spectrum number 1 minus 1.5 times the background, then you would end up with fractional counts also. So lamps doesn't have fractional counts, but here in root we have. So lamps has got only 2 of these, that is the the middle two, that is th1s, and it is called single word and double word. But here there are a total of 5 different types. These are the 5 different types of histograms, one-dimensional histograms. Similarly, you would have it for two-dimensional and also for three-dimensional histograms. So the first thing which you have to learn is how do you declare, how do you get this histogram going. So these are just the names of the types. How do you actually get such a histogram? So let's start with the common one, say th1 of type integer. I want to get this into my program. So to do that, I say that I start by typing th1i because that's the type of histogram I want. So I type that. Then I have to give it a name because there will be many histograms, and I have to give a name to the histogram. Just like if you, the equivalent is this could have been integer and it could have been x, but then there could be integer y also. So after giving the type, I would have to give the name of the variable. So my type is th1i, and the name of the variable has to be given by me. Let me call it h. So h is my histogram. The type of the histogram is th1i. In order to get it going, I have to specify something within the bracket, and that's going to be again the name. So this name is usually we give the same h. You could give it something else also, but then it would be confusing. So the name is h, and he has got a possibility to give the name second time. So that is given inside the bracket. Then he wants a title. Very soon you will see what is this h which I am putting inside and what is this title. So here I can put some title which is meaningful to me. So I have given it a title, my histogram. Then the next quantity which is to be put is the bins. How many bins? You see, in case of lamps, we were limiting to subsets of things like 10, it was actually 1K or 5112 or things like that. And it was going up to 4K or 64K or some such. That was the number of bins which you could have, and it was based upon ADC. This root is not for ADC data alone. It can handle ADC data, but it can handle all other types of data. So he doesn't restrict your number of bins to be things like 1K, 5112, and those kind of things. So the number of bins can be anything, whatever you want. In lamps, you could not have had 10 bins, but here you can. So I am saying that I want only 10 bins. So for my first example, I am going to have only just 10 bins, very small number, so that I'll be able to explain to you the things better. Then after having put the number of bins, he wants you to tell from where it starts and where it ends. So 0 is just an example. I'm going to start from 0 and I am going to end it at 100. So this is something which you could not have done in lamps. Lamps would have wanted to start at 0, but it would have ended at 4095, for example, or it could have ended at 8192 or 16384, but not arbitrary numbers like this. So he allows even negative here. So if you want, you can even start with -100. It's whatever you want you can have. So I'm, for the first example, going to start with 0, end it with 100, and I'm going to have 10 bins. So in this example, the range along the x-axis is from 0 to 100, and that has been divided into 10 parts. So the width of the bin is actually 10. So there are 10 bins. The first one will be from 0 to 10, then 10 to 20, then 20 to 30, and like that up to 100. So 10 bins in the range of 0 to 100. This is my definition, which I am going to use as an example. And the width of the bin for me will now be 10.0. So I put it, and this is what I get. So here you notice that I have two options. I can put it with the semicolon or without. I have put it without the semicolon, so it gives some information that the name is H, and title is my histogram, and the number of bins along the x direction is 10. If I had put it with semicolon, then he would be more quiet. And of course, in this case, I am doing it twice, so he didn't like, so this comment came. But if I had done it for the first time, then this comment wouldn't, wording would not have come, and it would quietly do the job. And if I put it without the semicolon, then it gives some information. Okay, so my histogram H is defined. So I have got my histogram ready. I now need to tell you a little bit about the bins, how the bins are numbered, and how we can uh, understand the binning system. So the bin number 0, the bins actually start from 1. So I told you there are 10 bins. The 10 bins are 0 to 10, 10 to 20, and like that. The first bin 0 to 10 will be called bin number 1. But there will be a bin number 0 also, and that is called as the underflow bin. So whatever is not able to fit in the bin, that is less than 0, if there is some number less than 0, that will come in the underflow bin. Similarly, there will be an 11th bin. Although we have said the number of bins is 10, there will be also a bin number 11, and that bin will hold the overflow. So numbers which are bigger than 100, they will go into the overflow bin. The other thing which you need to know is that what happens at the bin boundaries. So when I say 0 to 10 and then I say 10 to 20, suppose the value is 10, then which bin will it go into? Because you have said 0 to 10 and then you are saying 10 to 20. My number is 10, it is falling at the boundary. So the convention is that the lower side of the bin is the included one and the upper side is excluded. So if I talk about bin 0 to 10, it means 0 is allowed in the bin, but 10 is not allowed. 10 will go into the next bin. From 10 to 20 it will go in. So we have a number 10, it won't go into the bin from 0 to 10, it will go in the bin from 10 to 20, because on the upper side you have exclusion and on the lower side you have inclusion. So let's try it out, then it will be clear. So how do you actually, now next thing you need to know is how to display this histogram. Right now the histogram is empty. All that I did now was this command, and this created the histogram. The histogram is created, but it doesn't contain anything inside it. It is just empty. But still we can display it, and the command to do that is called as h.draw. So this is my command h.draw. When I execute this command, then it will actually be displayed. So up to now we didn't have any graphics. We were just doing command line, didn't have any graphs. Now I have to make way, so I am just creating some space here. So you will know when I execute h.draw, a graphical window will open up and it will display this histogram. So I did it, and this is your graphical window showing you the histogram. Now you have to notice various things about it. First of all, I told you that you will soon know what is this my histogram title which I have given. See this title, it's appeared here. So this is your my histogram title. Then you have to see that it has drawn a graphical window. This graphical window is called as a canvas. Canvas is a drawing object. It is a thing on top of which things will be displayed. So on his own he made a canvas, because we said draw, so he didn't know where to draw it, so he made a canvas. He gave the name of the canvas as C1. So this C1 came on his own, because we didn't yet, later on we'll see how we can define canvases and open them, but here we didn't. So he assumed that there is a canvas C1, and then he tried to display this histogram. The histogram is empty. So this is your picture. Why is the axis from 0 to 100? Because that is the range that we have specified. So he knows about the range. When you define 0 to 100, he knows that. So he decided to keep between 0 and 100 on the scale. But he doesn't have any idea about the y-axis, because the histogram is empty. So he just went up to 1. And I told you that fractions are allowed. In lamps, 1 would have been the minimum. 1, 2, 3, 4, it would have counted in the histogram as the counts built up. But here he allows fractions also. So now it's empty, so he's showing up to 1. So let's see how we can manually fill up this histogram as just as a kind of an example. So I'm going to say h dot set bin content. So this is my set bin content. Then I have to tell which bin. So I told you that bin 0 is not useful, it's the overflow bin. The bin start at 1. So if I want something like say bin, let's say 3, well, as example, in bin 3, and how much I want in it. Let's say I want 80 counts to appear there. So I say set bin content 3, comma 80. This command is going to create 80 counts in the bin number 3. So I execute it. 3 counts have come, but nothing happened in the histogram because I have to still update it. In order to update it, there are two ways. One is you can repeat this h.draw command. This is obviously a long way of, there should be a shortcut, but I'll show you this one first. h.draw. See, I got 80 counts in my bin number 3. Now to demonstrate how you can update it more easily, I will demonstrate another set bin content. Let's say that in bin number 5 I put let's say 40 counts. Now the histogram has got changed, but I want to update it by another method. That second method is I go inside the canvas, inside the histogram where it is plotted, and just one click of the mouse inside this, I clicked it, and you see it got updated. So here you see that there are now 2 bars seen here. So one is in the 20 to 30 region, and that is my bin number 3. And then I have in bin number 5 I have put 40 counts. So you can experiment like this. You can fill up more of the bins and have various different number of counts in it, and you can see how it works. Now I want to illustrate to you the overflow, and before I illustrate the overflow underflow, I would like to introduce one more command, and that is related to the values along the x-axis. This is the value of x. So what you saw by set bin content is bin number. So bin number is 3 and 5. What if I want to say that my x is 41 and I want to increase the counts corresponding to x equal to 41? I don't know the bin number. Bin number of course will be 5 for count that, but suppose I want him to calculate that and then do it. So I say h dot fill. So h dot fill fills it's the same as set bin content, except that it increases the count. Whatever count you have at that place, it will increase it by 1 unit. And at the same time, I should not give the bin number, but I should give the x value. So I am going to give 41. So 41 will come in this range, wherever at present I have got 40 counts there. If I execute this one, then at bin number this value is 41. Now it could be 42, it doesn't matter, something in that range. At present I have 40 counts, and the number of counts will increase. I should get 41 counts now after I execute this command. So I executed it and I clicked it once here, and see it went up slightly. So I got one more count over there. The shortcut to h.fill for many counts, h.fill 42, and then you can also give a number, how many you want. So I want to increase it by 100 counts in one go. Then it will give 100 counts more, and now you have 41 counts, so it will go to 142 counts. But at the same time, one more thing will happen, which you will see. It will disturb my histogram plot substantially. This you will understand now. So I did it, and now when I clicked it, you see what I got. Somehow the things have got apparently disturbed. Actually nothing much has happened, but the display of histograms is having more than one form in which he can display. This is called as an error bar display of a histogram. So when I tried to fill it like this, he thought that I am interested in the error bar plot. Actually, I am not. So I should go back to the normal type of plot, and that can be done by h.draw. But in h.draw, earlier on we were not putting anything inside the bracket. Now we will learn this command. So h.hist. This is your command by which you get a regular histogram plot, which we are more used to seeing. And if you want to know what are the other types, then there is this error bar plot which you saw just now, and I will introduce you to the other types also right now. So the one with E, this is called as an error bar plot. So this looks like this. Each point in the histogram, you had counts only in two places, other bins were empty. Here you had counts, and the horizontal line indicates the width of the bin, and the vertical line indicates the error bar on the count. So let's go to another type. Another type is L. L means line. So display the histogram but with line. So in that case, I didn't have a result here. Let me go back to the histogram first and update it. Okay, so yeah, now I wanted to try with L. So this L is giving me the same thing, namely error bar, and there are few more types. Lego is a brick type. So this is my histogram displayed as Lego. This you will see useful later on when we do the two-dimensional histogram. Right now there is no much information coming out of this one. Okay, so I showed you the different types of histogram plots which are possible. I will show you more about this later on. So for now I go back to the normal HIST type of plot, which is more familiar. Now I want to demonstrate to you this overflow and underflow business. So you learned a little bit about histogram and how the counts can be placed in different bins. How can we increase the count, then how can we fill. But now I want to demonstrate the overflow and underflow parts. So suppose that the value of x is actually below 0, and I try to fill this histogram with a number below 0. So there is no bin below 0. The bin starts from 0. 0 to 10 is the first bin. Set content in the first bin. So set bin content, if I do in bin number 1, so with up arrow I can recover old commands and then I can edit it. So this is useful for getting back some commands. So if I want to put, let's say, 3 counts in bin 1, then this is my command. Okay, so see, 3 counts have appeared in bin 1, but there is a bin 0 also I mentioned, but I can try to set it there. So 0, let me put 10 counts in bin 0. I put it. This is actually the underflow bin. So 10 counts have gone, but my axis range doesn't show it. So there is nothing visible in this graph because the range is not there. For the first thing I am going to do is to change the range for you so that you will be able to do it. So I do H, then dot, then set axis range. And here, instead of starting from 0, let me start with minus, let's say, 20. This is just an example. You will soon see that what happens. I am putting a little large numbers here, and then I update it. But when I do it, he doesn't really take, like minus 20. He just goes up to minus 10 only, and after 100 also he allows only one more bin. So although I tried to set a bigger range, he knows that that is not possible. So he restricts the range intelligently to valid values. But you see, I have got now one bin after 100 also, and I have got one bin below 0 also. And in that bin which is below 0, that is called as the bin number 0, I have put 10 counts. Now you see that over here. So 10 counts are seen. It's the underflow bin. And similarly, if I go to setting the bin content in bin number 21, this is the overflow bin, I'm going to put, let us say, 100 counts there. So, and then when I update it, it doesn't want to update because he doesn't really want you to fill this bin number 21 with counts. It's an overflow bin. You will see that it does get filled when X values are there. But with set bin content, you cannot go to the bin number 21. Bin number 20 is the last. If you were to set it on bin number 20, 100 counts, then it would be possible. Now it has stopped updating. Just 1 minute. Yeah, so occasionally it happens that there is something little bit misbehaving, so he is not updating this histogram. I will going to do an h.draw. Yeah, so this is what I have. The number of bins was actually 10, so you see that's why it was not working. That was the problem. I was trying to put something in bin number 19 or 21, so that's not correct. There are only 10 bins. The last bin is bin number 10. So this is bin number 10. And if you try to go to bin number 11, then see. So I could put 100 counts even in bin 11. After that, there is no bin. So this bin 11 is the overflow bin, and in it I have put 100 counts. I could have put some other things so that it would be more clear. Let me put say 50 counts, and now you can see that. So this was about underflow and overflow. How you can get counts in the underflow and overflow bins. Now let me go on to some more things, so which you should know. One of the commands which you should know is h.reset. So this actually clears the entire histogram. So h.reset will clear the histogram. So now nothing is there. Everything, all the contents have gone. And in addition, I want to show you one more command, that is get bin content. Just as you have set bin content, so suppose I put 50 counts at bin number 5, and if I want to get it, I want to know what is the value there, then that command is get bin contents. So I want to get bin content. I don't want to draw it again. And 50 is going to be the answer, not what I already know. So I want to get the bin content at the bin number 5. So this is my command, and it should be put without the semicolon because I'm expecting a result. So I do it, and he says the answer is 50.0. So in this way we can get the content of any bin also. Now for the next few commands, I need this histogram to be slightly filled up with counts so that I can show you how to introduce various colors into the histogram. So what I'm going to do is, let me set counts at various places. For example, at bin number 1, let me put let's say 10 counts. At bin number 2, let me set say 20, and then at bin number 3, let me put, say, oops, let me say I have 25 counts, and then in bin number 4, let me put, let us say, 30 counts. These are just some examples, and I'm just trying to fill up the whole histogram. Okay, that should be good enough. So I filled the histogram. I didn't fill all of them, so I filled some numbers here. Now I want to demonstrate to you how you can assign colors, and that is called as the histogram styles. So let's do that now. So command is h dot set fill color. So I am going to put some color, let's say 3, and then we are going to update this. So this is how the histogram got filled with a certain color. There is also an h dot fill style. And then you have to put the style number here. These style numbers are, they do start with 0. 0 is hollow. I'll just keep the h dot draw over here also, so that it updates automatically. So fill style 0 will make it hollow. That means it will remove the color. But I can also choose, yeah, so for the solid color it is starting from 1000. So 1001 will be the back to the filling the color, whatever color we had set. Color was 3. And if you want some patterns, the patterns, they start from 3000 onwards. So I am going to give an example of pattern number, let's say 21, and then you can see that you have got some pattern fill inside the histogram. Then there is also the line and the line colors. So you can see how you can set the line color. So set line color. The color numbers will be a small number between 0 and 255. So let's say I put say 11. So I put 11 as the set line color. So you see the color of the line, this changed. Then the width of the line. So set line width. Now the line width will be, let me put 3, otherwise it will be too thick. So you see I got the line color, line width to be 3. There is also line style, which include dashed lines and so on. So set line style, let me say 2, so that I'll get something like a dashed line. So I get this dotted line. Now so this was some of the things which I wanted to demonstrate. Now we are going to do some of the things directly from the graphical window. So whatever you saw now, this is called command line. So we do some things from the command line, and the effect of it, that starts showing in the canvas. Can we not do something on the canvas itself with the mouse, so that we don't have to go on typing all these things? So yes, to some extent we can. The full control actually comes from the command line, and some control is possible from the interaction by the mouse also. So let's try. One of the things is that this is the axis. So you see my mouse pointer changes according to where I am. If I am on the axis, then I get this hand one. Now, if I want to zoom it, unlike lamps was wanting you to mark like this with a drag, but here that will not work. For changing the range, here you have to actually come into the axis and mark it like this way. So I started in one place and then I'm releasing it, and then I don't have to say zoom, automatically he zooms it whenever you mark it. Now I want to unzoom it, so for that again I put my mouse on the axis so that it changes to a hand cursor, then right click. Now there are many options here, one of them is unzoom. So I click now, it's very small, maybe not readable for you, but one of the options is unzoom. Click that and then you get unzoom. Of course, now he doesn't like to show the underflow, so you notice that underflow and overflow is gone. But anyhow, he unzoomed it to the extent that we wanted. You can do the same thing for vertical axis. So if you do like this, then this zooms it that way, and then again the right click and unzoom. Okay. Now let's see how we can do more from the graphical window itself. I will temporarily enlarge the graphical window so that we see it better. And so apart from zooming, which I have demonstrated, let's try to uh, see how we can uh, do something from here. So I'm going to click view. So in view, and then I'm going to click editor, and I'm also going to click toolbar, these two things. So view, let's start with editor. So view editor. So this is my view editor. It opens up a pane on the left hand side, and this thing has come which was not there earlier. If I were to view and say toolbar, then I get something along this toolbar line also. These two things I can do. Now the way that this left panel here works is that it is very much sensitive to where I am with the mouse. Right now he is showing that he is in the canvas. That is because we are clicked somewhere here. If I click somewhere here, then you see he changes to T frame. If I click here on this curve, then he says TH1. If I click here, then he says statistics. So if I click here, then he talks of y-axis. If I click here, then he talks of x-axis. So it depends. This is very much sensitive to where you are, and then the items here, they also change. If I click here, then he is talking about the canvas, and then he says style. So he is asking for the style of the canvas, and the fill color is showing here as white. So if I want, I can just change the fill color from here to something else. So I am clicking this blue color here, and then you can see that my canvas color has changed. So you can make some changes like this also. Let's try to see what I can do here. So now I am in the frame, T frame. T frame actually is only the outline of this, not this full part. So here he talks of only line. So only the color of this line, which is constituting this frame, this can be changed. If I choose let's say red as a line, and if I were to change the thickness of the line to large value 10, so that you'll be able to see. So here I could make a frame like this. Okay. What else can I show? Let's click the histogram now. So in histogram he has got two things, style and binning. So under style are usually all these colors. So at present there is a green color, and then there is a fill type showing up here. So I can go back to white, and it will become like that. Then he has got a line. The line, I can make it black. I can change the thickness according to whatever I want. So this helps me to, I can change the title from here also. Okay, so these are some possibilities. Then regarding the other parts of the styling here, instead of showing the things like this, I can ask him to show it with show markers. So this one shows markers, but the markers are invisible because the marker is very small. So from here I will have to first change the marker type. uh, let's say I choose something like this as a marker type, and I make the marker type big, and then I ask him to show the markers. So you see, with the help of the markers, the plot has been made. I could also draw bar chart from here. So this is the bar chart. This is, you already know. And then this error bar simple is possible. Different types of error bar options can be selected from here. They are not uh, making any difference in this right now. Now let's go to binning. So I am now from here I have gone to binning. It is telling you that there are 10 bins. This we already know. It's also showing you the x-axis range from 0 to 100. So first is this slider here. So with the help of this slider, we can go to a change like this. So by moving this slider, the range of the axis is being changed. Of course, you know how to do that from zooming by marking along the axis. This is another way. But interesting is rebin. So here he says the number of bins is 100. If you want more bins, you can just drag it from here. So for example, here now the bins is 5. So now there are only 2 bins. So this way, of course, we cannot have more than 10 bins because the data is already histogrammed in 10. So what we can only do is we can now have 5 bins or we can have 2 bins. Nothing else we can do, because if you go from 10 to 5 bins, then he has to just combine two bins and add up the counts, and he can do it. And if you have only 2 bins, then he has to add up for the first 5 bins and the next 5 bins. So he cannot do rebinning in a very general way, and you cannot bin it with more resolution than which you already have. You can only do less, and that too it should be a multiple, or rather a factor. So my bin is 10. The factors of 10 are 5 and 2. So the rebinning is possible in 5 and 2, nothing else. And if you click then apply, then he will ask whether you want to change this binning for the whole replace the original histogram with the rebinned one. So I'm going to say no. Then the change will become permanent if you were to make the change. Okay, that was about binning. Now little bit more. For today we will not do a lot more, just a little bit more. So let's see 1 or 2 more things and then we will stop. Okay. When you are tired of seeing these colors and you want to start a fresh canvas, then you can do from your file and then quit. Don't quit root, because then this will fully stop. This also you can do, but you can close canvas. So this one is gone, and now we want to do some other example, or on this example itself. So if I do h.draw, I will bring up the canvas once more. So this is my histogram, and now I am going to, why all the colors disappeared is because the previous canvas was destroyed and a new canvas was built up. So all the properties of the previous canvas, they are gone. and a new canvas has been started, histogram is still the same. So there is a command to get the integral. So if I want to know the total number of counts, that is called h dot integral. So I can ask the integral, then I can give it a range. So if I want from all, so I can start with bin number 1 and end up with bin number 10. This will be all the total counts, and that comes to 127, for example. If I were to give it starting from bin number 2, then I get 117. So it depends on the range of your bin numbers, and then you can add up the count. So this is another command. Okay, now I want to show you something different. So one of the important things is the way that we defined. So if I just scroll back to how we defined this histogram, this is the OR command by which this histogram was actually defined. So there is a second way in which we can do this. Instead of using this command, another command, it uses the pointer type. So in that case, let me call the new one as h2. And just to be different, let us have 20 bins, and let us go from 0 to 200. So this would be one way of defining it, but the second way of defining it, which I want to show you, is that we put here star so that it becomes a pointer to the histogram, and then we say equal to, and then we say new, and then we of course give it here the th1i. So h2 is now a pointer to the histogram of type th1i rather than the histogram itself. So those of you who are familiar with pointers, and if you're not familiar, then don't worry, it will become clear soon. So now my histogram is h2 is defined. So this is equivalent to the previous command. But now the difference is that previously, for h I was doing h dot draw, so I would have said h2 dot draw. This command will fail in this case, and because now h2 is a pointer to the histogram, it's not the histogram itself. So h2 draw will not work. What will work is h2 arrow draw. So if I by mistake were to do h2 draw, then he will say that it's a pointer, and he will himself say that did you mean to use arrow. So he understands my mistake. The mistake is that it should not be h2 draw, it should be arrow. So what happened here, I don't know. Oh, sorry, so I didn't put the arrow properly. Yeah, so now it is here. It's an empty histogram, so that's why, but otherwise the command is now correct. So if h2 was to be filled up in the same way that we filled up, and then we could draw it in this way. So I wanted to show you the second way of defining a histogram as a pointer and then using the arrow commands. So here you would have done h2, then arrow, and then set bin content, bin number, counts, and then it would have happened, and then if you click here, then you see the histogram updation as before. Next thing, almost at the end of today's lecture, I am going to show you something different, and for that I am going to define, let me kill this one, let me define something which is a floating point type. So th1, instead of integer now I choose f. F is a floating point type, and let me call another histogram. So let's say h3. The name of the histogram is h3. Then I'm going to give it a name because I'm going to fill it now with random numbers. So I'm going to call it as my random histogram. And let's say the number of bins is 100, and I'm going to go from -5 up to +5. So this is my histogram, and then now let me fill it. So h3 dot, instead of doing h3 fill, command is known to you, fill, from earlier, but I'm going to fill it with random. So I fill it with random values, and then I give the function name, in this case Gauss. So I'm going to use Gaussian random numbers. So this is your Gauss random function. Then how many numbers I want, how many random numbers. So it won't look good unless you have a large number. So I'm going to put 1 lakh of them. So I put 1 lakh random numbers inside this. So that's done, and now I'm going to draw it. And now you should see a Gaussian random filled situation. So this is my random histogram with filled Gaussian random numbers filled in there. Let's see how we can do some fitting. So this is one thing to be explained now, is how we can make a fitting to it. So that's just a simple command, h2 dot fit. This will fit a Gaussian around it if I select the Gaussian function. So Gauss again. So this is now this is h2 dot fit. He wants an arrow. Oh, it's because it's h3, sorry, h3 dot fit. Yeah, so you see the Gaussian has been fitted for this data. The values of the parameters are given. The first quantity called constant is actually the amplitude of the Gaussian. Its value is 4000, and then the mean is supposed to be 0, so it's close to that, and then the sigma or standard deviation is given here is around 1. So this is how